Hello students, welcome to the online classes, Standard 7, Subject Maths. Exercise 14.3, 14.1 and 2 already we have completed. What is the name of the lesson? It's a symmetry. First question, name any two figures that have both line symmetry and rotational symmetry. So what kind of these two figures which is having both line and rotational? It means if you are going to draw horizontal, vertical axis or diagonals, then also it is having symmetry, line symmetry, and you are going to rotate that figure, okay, then also it is the same. So such kind of figures are circle and square. Here is a circle, you can rotate this circle at 90 degree, 10 degree, 5 degree. It will look same as the first figure. And here circles, this circle is having infinite number of line of symmetry. Second one, square. Okay, so total 4 lines of symmetry, and circle is having rotational symmetry also. What is the order of this rotational symmetry? It is a 4. Question number 2. Draw wherever possible a rough sketch of. Here questions are given. With the help of this question, think and draw figure. What is the first one? A triangle with both line and rotational symmetries of order more than 1. So first of all, 3 kinds of triangles are there. 3 types of isosceles triangle, equilateral and scalene. First one, in equilateral all 3 sides are same. In isosceles 2 sides are same. And in scalene all 3 sides are different. So you have to draw a triangle which is having both line and rotational symmetry more than 1. So it is a equilateral triangle. Okay, so total number of line of symmetry is 3. In rotational, see, in isosceles triangle, the sides are same only, so rotational symmetry will not be possible. So in equilateral triangle, rotational symmetry is also possible. You can rotate this triangle at 120 degree. Second one, a triangle with only line symmetry and no rotational symmetry of order more than 1. So line symmetry only, so that is isosceles triangle. Just now only I told. Okay, in isosceles triangle one line of symmetry will be possible, but rotational symmetry will not be possible. Third one, a quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. Quadrilateral, so it's not possible to have a rotational symmetry is more than 1. Not okay. What is the question actually? Rotational symmetry is possible but no line symmetry. So if line symmetry is not possible, it means rotational symmetry will not be possible. Last one, a quadrilateral with a line symmetry but not rotational symmetry of order more than 1. Line symmetry is possible but rotational symmetry is not possible. So yes, trapezium is there. Okay, in this trapezium one line of symmetry is possible. This is the trapezium, this kind of, so line of symmetry is possible but rotational symmetry will not be possible. Question number 3. In a figure has 2 or more lines of symmetry. Should it have a rotational symmetry of order more than 1? Yes, because every line through the center forms a line symmetry and it has a rotational symmetry around the center of every angle. So any figure is there which is having line symmetry, okay, more line, 2 or more lines of symmetry. So this will be passing through the center. this line symmetry. So it must have a rotational symmetry also, and that will be around the center for every angle. Fourth question, fill in the blanks. Square. Center of rotational, center of rotation. What will be the center of rotation? This way, intersecting point of diagonals. Okay. Then in rectangle, intersecting point of diagonal. In rhombus, also it is the same. Then triangle. What is a triangle? Intersecting points of medians. In regular hexagon, also diagonals. Circle, center. In circle, center is there itself. Semicircle, midpoint of diameter. So this is a diameter and here it's a midpoint. That will be the center of rotation. The next, in square, what is the order of rotation? 2. Sorry, it's a 4. Okay, this we have seen before. So up to equilateral triangle, you know, up to hexagon, you know. Then circle, infinite. Semicircle, only 1 only, because here it's a semicircle. Rotate, then it will be this one, third one, this fourth one, this one, and again in the fifth one you will get the same one. Okay, then angle of rotation, 360 divided by 4, 90. 360 divided by 2, 180. Okay, 180. Then 360 divided by 3, 120. 360 divided by 6, it's a 60. Infinite, it means at every point. And 360 divided by 1, it's a 360 itself. Fifth question, name the quadrilateral which has both line and rotational symmetry of order more than 1. So it's a square. Very simple. Question number 6. After rotating by 60 degree about a center, figures looks exactly the same as its original position. At what other angles will this happen for the figure? I think this figure is given in the textbook. And first point of rotation, 60 degree. Okay, so you are going to rotate this figure at 60 degree. Then it looks exactly same as the original position. Then you have to find out the other points, other angles, okay, where it will be happen. So 62 is 120, 3 is 180, 4 is 240. You have to multiply by the natural numbers. Okay, so up to 360, because 360 after it's not possible, so last point is 360. Okay, so here it's given, you can see. And how many times it will rotate? 60 degree, 1, 2, 3, 4, 5 and 6. Okay, so 6 times it will rotate. Question number 7. Can we have a rotational symmetry of order more than 1 whose angle of rotation is 45 and 17? If the angle of rotation is 45, then the symmetry of order is possible. Would be 8 rotation. 45 into 8 is equal to 360. Okay, so 360 divided by 45, it is a divisible, it means it's a possible. Then 17 degree, if order rotational symmetry of order more than 1 at 17 degree, 360 divided by 17 is not possible, so symmetry of order is not possible. Okay, this is the answer. So here this chapter number 14 is over. All this you have to write in your fair notebook, all this exercise, and you have to practice it. Now next chapter we will start in the next lecture. Thank you.